In this video, I will walk through how to initialize a window and draw shapes in Raylib. So Raylib is a beginner-friendly library for game and simulation development. It is open source and cross-platform, and has bindings in virtually every language. So you can program it in C, Golang, Python, C#, anything you can think of. But because it is written in C, I will be using that for this video. So I expect that you will be familiar with C going into this video. Additionally, you also have to have CMake installed, which is how we will set up the Raylib library on the computer. So the first thing in every Raylib project is to obviously include the Raylib library. And we do that through CMake, where we just find the Raylib library on our computer, and then we import it in our source file by just including raylib.h. And all of this code will be on my GitHub portfolio, so you can always just copy paste this. It's nothing too complicated. It's just you're looking for the library and then you're adding it. You're linking it to the project. And this is just if you're on Mac, this links to target libraries. So your file will compile without issues. So the first thing you want to have in your project is obviously your main function, where you will have your main code for the project. So in this case, what I want to start off with first is to set the configuration for the window. So I have vsync enabled, and I also have high DPI mode enabled. And what those do, vsync, it just synchronizes the game's frame rate with the monitor's refresh rate. So because I'm on a laptop and the maximum frame rate that the monitor can display is 60 frames per second, it is going to make sure that my game runs at 60 frames per second. And in addition to that, I also set the target FPS to 60. Additionally, I also have high DPI mode enabled, and that's because I'm on a Mac and it's a Retina display. So if you are running on a Retina display, you want to have this enabled. And after that, we just initialize the window with the width followed by the height and then the title of the window. And I have here in globals.h, which I just included over in my main.c file, I just have the width set to 800, height set to 450, and the title set to tutorial. And I also have some colors here just to make things easier. Although you can use the built-in Raylib colors, so you don't really have to worry about this. After that, we have the game loop. So while the window should not close, meaning while there's no intention from you to close the window, so you're not hitting the close button, or you're not hitting an escape key if you program that in, then this will run, whatever is in this loop here. And the first thing we want to do, obviously, is to tell the program that we want to start drawing. And then we draw or render the text and shapes and whatever we want to render. It would go in this function, which, as you can see, is defined here. And then after that, we end drawing. And then once we do intend to close the window, we will tell Raylib to do so, and then we would just return 0. So in the draw file right here, in the draw function, we have the ability to draw, Raylib gives us the ability to draw circles, rectangles, triangles, and even pixels. And there are more than just that. So you can go to the cheat sheet Raylib here, to the Raylib cheat sheet here, and you can see that right here, drawing related functions, there's a lot of them. So you can look at this and it will give you a guide on everything that Raylib really has to offer. So back to the program. If you want to draw a circle, there are two ways to do this, or really for any shape, there are two ways to do this mainly. You can draw it with a vector, or you can draw it with the values for the position separately. And what I mean by that is here. So we have draw circle, and then we can enter in the x coordinate and the y coordinate in separate parameters. So I can do like 3 and then 8 and then the radius and the color. Or alternatively, you can just use a vector, which I'll be using which I'll be using for this video. And vectors are just a way to represent a coordinate on a 2D plane. And in this case, since we're using vector 2, it's just 2 coordinates. Or sorry, it's 1 coordinate with 2. It's 1 point in 2 dimensions. And it would be 30 and 40. And then after that, we would have the radius. And the radius of the circle is going to be 30. And then the color. And I'm just using color red, which is defined here. And this is the RGB value, as well as the alpha value. Although you can just use the Raylib pre-built red, and it'll work just fine. But I think I prefer my colors. You could also do the same for rectangle, but in this case, we have the position, the size, and the color. They're all vector 2 as well. Then we have the triangle. For the triangle, we have to... There's actually, I think there is no way to draw a triangle with the coordinates separately. Each point is a vertex, and the vertices are all represented by vector 2s. So we just have 3 vertices here. This is 1 vertice, another vertice, and then your third vertice. Let's do this maybe, I don't know, 120, and then green. And lastly, we can render a pixel, and you probably won't be able to see this because it's just a pixel, but it is possible. And let's just render it at this position here. It's also a vector. This is also a vector. And color green, well, maybe let's just do color underscore, let's do black. And after that, we clear the background, so it resets, every frame, it resets what's on the screen with the color white. But it also redraws. But this is for if you want to move, let's say you have like an update function, and you want to move a circle, and then you like change the position of it every frame. So this would redraw the circle. That's basically what that does. And once we hit run, so to run, you just go to terminal, and then I defined a shell script that just runs this because I'm using CMake. We build the CMake project, and then we run the tutorial executable. So here we just do run.shell. And as you can see, all the shapes are here. They're kind of clustered in the same quadrant of the screen. So let me see if I can change some of this stuff. Perhaps let's move the rectangle. So the position of the rectangle right now is 30, 40. Let's move this to like 300, 400. I think this should be fine. Let's rerun. Oh, there. As you can see, we do have something else on screen here. This is the rectangle, then the circle, and then the triangle. And that's pretty much it.